Hi, this is our Engineering 300 project. Our group consists of Jenny Sainan and Faris Mansour, and we are going to be talking about machine learning and how it affects the online advertising industry. We are going to be looking at how machine learning was approached and what needed to be done in order to collect accurate data. Also, machine learning can solve the problems that does not have a mathematical equation. Therefore, through MATLAB, we are going to be using SOM or self-organizing map, and we will discuss it more in this video. As I mentioned before, our project is based on the machine learning in online advertising industry. So our objective is to find consumers who are most likely to purchase a specific product and then target the audience. The system will depict which consumer should view specific advertisement. Therefore, machine learning is a vital component in optimizing online advertisement. How did we approach machine learning? First thing, when a consumer performs any actions, we take those actions and we store them into a dataset. Using machine learning, the system gathers thousands of different modules automatically, and it learns a new different modules from each new campaign. The system generates an algorithm that can then analyze a new consumer's behavior. After that, it transfers data into a real task and outputs the most likely to succeed advertisement.
The neural network must cluster users from previously collected data in order to compare new users to the clusters. The clusters are determined by grouping the data points with many similar attributes. The objective of the cluster is to allow the system the capability of determining which advertisement will most likely result in a consumer purchase from only one impression. When a new user interferes with the system, the inputs defined by the user's computational activity can be compared to each of the clusters. Due to the fact that the ultimate goal of the system is to generate the greatest revenue based off of targeted advertising impressions, a cluster should incorporate the revenue generated input in order to determine the advertisement that is likely to generate the largest revenue of a targeted audience. The inputs that were used are to follow: the revenue generated by each consumer, the gender of the consumer, and the advertisement that was used, and the number of times a keyword in each of the preceding categories was searched or clicked on, such as sports, women's clothing, men's clothing, technology, furniture, and glasses. The training set uses data from only the consumers that resulted in revenue generation, or in other words, the consumers that made a purchase. For the purpose of this research, we have randomly generated this data based on multiple conditions. In order to accurately determine which advertisement would be the most effective when displayed to every individual consumer, we must create a self-organizing map to organize the data set into 36 different clusters to determine the dependency of each attribute on one another. The neighbor connections plot displays a 6x6 matrix, or 36 neurons, and the connections between each of these neurons are clusters. The sample hits plot indicates the number of data points included in each of the 36 clusters. The input planes plot shows the similarities between each of the neurons according to the individual inputs. We are able to refer to the neighbor connections plot to view which of the neurons are being connected. The distance or similarities between two clusters is displayed by the color within the connecting hexagon. The lighter the color, the more similar the clusters are. The darker the color, the less similar the clusters are. In the input planes plot, the dependency on each of the inputs are displayed. The neighbor distance plot is very similar to the inputs plane plot. However, it is a plot that describes every attribute. The bright colors represent a smooth distribution of attributes and the dependency on each of the attributes. The weight positions plot is used to analyze the distance between each of the neurons within the first two attributes, revenue and advertisement displayed category. The green dots represent each data point, and the larger black dot are the clusters of each data point. This plot is especially important when determining the success of an advertisement. The further the cluster is to the right on the weight 1 or x-axis, the greater the revenue. This being said, we can see that the consumers who were shown advertisements pertaining to women's clothing and technology or glasses generated the greatest revenue. In order to use the system of clustering consumers, it is important to notice that when a new consumer interferes with the system, the amount of revenue generated is not yet known. This being said, one must compare the user's data to each cluster not based on revenue, rather based on attributes pertaining to the user's online activity. The clusters with the largest revenue should be compared to first in order to use the advertisements that are most likely successful.